Hello everyone, welcome to the sixth lecture of the railway engineering. Today we are going to see methods of creep. Right? These are the defects that we see. These are the effects when the train moves over the rail. These are the defects of rail. Okay, we are going to see how to reduce or what is creep, wear and tear, and how to prevent this or how it happens. So all those things we'll see today in this lecture. Methods to reduce the creep, right? See, the creep is very important. So before going to creep, we'll study about the wear. So study wear. A rail may face wear and tear, as I said. Wear and tear is nothing but due to the continuous movements of the trains along the length of the rail, right? The top surface or the top head of the rail will start wearing out, start getting damaged, right? It start getting damaged. So that happens due to the friction of the tire and the rail. So that is called as wear, right? On the top of this may occur on the top of the railhead, right? On the sides, because the flanges may just come in contact with the rails, and the sides of the head may get road on, where is most prominent for the following locations. On the sharp curves due to the centrifugal force, as I shown in the previous class about the coning of wheels, right? So that time what happens, the wheels will try to move outwards. So due to that, the flanges of the wheel will just touch the sides of the wheel. So due to which there is wear and tear, right? Due to the steam gradients, due to the extra force applied by engines, due to the steam gradients, the engine has to howl for a larger energy, due to which there is a drag force created. This drag force will create wear and tear over the rails. Right? On the approach to the rail stations, possibly due to acceleration and decelerations. When the train comes to the station, right, either it starts from there or it stops at the station, right? So when it is trying to stop, it applies the brakes, so that there is worn out continuously, because there are a lot of number of trains every day coming and going there. So that the wear and tear may occur at the stations also. In tunnels, coastal areas, due to the humid and weather effects, this may occur, as we know, because it is a high carbon steel. Due to the humid conditions and dry and wet conditions of the weather in that area, the rails may start corroding. It will not corrode so easily, but over a period of time this may happen, due to which there is a chances of wearing and tearing. Can you see this image here? This is wear on the head, right? And can you see this image here? This happens when continuously movement of train happens, right? And sudden brakes are being applied. So you can also see that this side here, right? This portion is also, sides of the head are also worn out. This is what happens when continuous movement happens, right? Can you see the side heads been fractured or getting? You can see the fracture also here. Right? Due to the movements and without proper maintenance, this happens, right? You understand what is wear and tear, right? What is wear now? When you see the image, you'll understand easily, right? Actually, this is how the rail has become. The top head is not there only, right? Can you see the top head? No, it has shrunk. You see creep. Creep is nothing but it is a longitudinal movement. Creep is very important term in the railway, and this is asked in the exam very commonly. Creep is a longitudinal movement of rails in a track. Creep is common in all the railway tracks but varies in the magnitude considerably. The rails in the place move for several centimeters in a month, while in the other locations the movement of the rails may be negligible. If I want to show you, if this is your rail, this is the head and this is the bottom, right foot. This is the end of the rail, right? We provide some joints, right? This like this. Right? This is how it is actually. But due to the movement of wheels over this direction, right? If suppose the force applied on this is in a steeper gradient like this, right, like this, due to which it requires larger force to be applied over the rails by this, right? It is applying a large load by these wheels over these rails. While moving forward, what it does, it drags the rail along the length of the road. If this is your length of the, right, if this is your length, right, if this is your length, if you see from the top, this is your rail, right, and if you have the movement is in this direction, if the movement is in this direction, so what will happen, these rails also move for few centimeters forward, right? This also move forward. If you see in this case, right, if you see the same example which I have given top, after a month you will see like this. The gap which was there before is not there now. See it. Can you see this? The gap which was present here, right? It is not available here now. It has moved and the gap has been closed. So this should not happen. So this is happening. The movement of the rails along the length of the rail. What is the length? This is your length, right? Along this length. On the direction of the movement of train. In which direction the train moves? In direction that creep occurs. Depending upon the, if it is steep gradient, it will move up downwards. If there is a curve, then it depends upon the direction of curve it moves. So depending on those all characteristics, there is a movement of the track. And so that movement along the length of the train, along the movement of the train is called as creep, right? It says it's a longitudinal movement of rail, right? It is longitudinal movement of rail, right? Creep is common in all the rail tracks, but the gap which is covered, the movement that we see, that varies from place to place, right? Can you see? If you see this image, right, previously, right, it was had a gap here and we have provided a fishbowl. You can see a fishbowl here. This is how a fishbowl looks. Here also you can see fishbowl, but this gap is not there in this case. Can you see? It has just gone and connected to it. It has merged with it, right? Can you see this? right? By applying pressure, it has distorted the this, and it has just went inside. So due to that, what happens at one side, if this happens to this side, then the other side of the rail will have more larger gap. If it comes and connect to the one side like this, then the other side will have larger gap. That should not happen, right? And as we know that the joints is the weakest points of the rail track. These are the weakest points. So this is how creep happens. What has happened? This track has moved inside this track, right? It has become like this, right? This gap is not there now. This gap is not there, right? Understood what is creep now, right? Because the movement of the track along the length of the rail track or along the movement of the train. The causes of creep. First, one must understand in deep which are the causes. I have told you, but once again, we'll see. Ironing effect. Due to the creep, what happens? Ironing effect of the wheels. Ironing effect of the moving wheels on the waves formed in the rails, tending to cause our rail to move in the direction of traffic, resulted in creep. You might have seen that this type of curves are formed due to the wear and tear, right? These corrugations are formed small corrugations are formed along the movement of the train, like this, in this direction. So when it goes over such corrugations, what happens? It will drag the track along with it, because there is obstruction to it, right? It is dragging it now. So due to that, creep occurs, right? First effect, change in the temperature. Temperature variation causes unequal expansions and contractions in the rails. Creep is more in the hot weather than the cold weather, right? So what happens? Creep also occurs due to the ironing effect, that is, due to the corrugations, the disturbance occurred to the track or the wheels of the train will move the track in the forward direction. So due to that, creep occurs. Due to the variations of the temperature, uncontrolled or unequal expansions occur. This creep occurs more in the case of hot weather. Creep is also caused due to the force that comes into operation when it starts to push the vehicle tails backward when it stops, and when it stops, wheels will push forward. When you start the train, right, at that time on the stations, it will try to move forward, but it will push the rails backwards. Right? Same thing happens when you stop the wheel. When you try to stop the train, right, it try to go backward, but it will push the rails forward, right? When this is what wave theory or ironing effect. It is also called as wave theory of creep. So when these corrugations form, right, when these corrugations form like this, when you try to move forward, it will drag the rail also forward. So that is what causes creep. Track alignments. Creep is more on the curves than into operation when trains stopping the wheels or push forward. It is trying to say that the creep occurring on the curves is more than during the start of the engine, during the start of the train, or during the stop of the train. As we saw, while applying brakes when starting the vehicle, that is your train, you see the creep, but that is lesser than the case of curves. You will see more creep in the case of curves. Track gradient. Creep is more on the steeper gradients than the straight tracks. Right? Poor maintenance. Track is not maintained properly, more creep is developed. Fish plate and fish bolts will lose. Right? Now, what are the effects when a creep occurs? We know why it occurs, right? So, if it occurs, then what will happen? That we'll see today. Displace, displaces the sleepers from its position. First thing it does, creep will do, right? Disturbs the gauge. It will displace the sleeper, and it also disturbs the gauge. Tends to open the rail joints. As I said, at one side it closes the joint, right? It closes the joint, but on the other side it tends to open the joint more, right? The displaces the points and crossings also. So very dangerous thing it is to displace the points and crossings. It causes a problem for carrying out a repair works. Rails removed from the purpose cannot be easily fixed in position. And when the creep occurs, to bring it becomes very difficult. Back twist plates. It causes battering of the rail ends. Right? This will happen. Right? If this has happened, this is a one rail, right? This is rail 2, right? So this is a second rail. Now creep is occurred here. This rail has moved into this rail, right? Now, so when it moves this side, right, here there is lot of gap. Here there is lot of gap. When wheels will try to move on this, right? When wheels will try to move over this edge, because of the gap, what happens? There is battering of it. Means what? I will show you. Right? The edge which was there previously has worn out. Right? This edge has worn out. Battering, there is a polishing done like that. That happens. Right? It disturbs the alignment of track. It also disturbs the alignment of track. It will displace the material of ballast. It will displace the material of ballast. Operation of switches becomes difficult because we have changed the points and crossings. We have replaced it. We can't properly do the switching work. Now, how to prevent this? We know how it causes. When it causes, what happens? Now, how to control this creep? Creep is adjusted by adopting following methods. Pulling back the rails, right? We have to pull the back rails, but you have to do it monthly. You have to check it whether there is any creep and do it. Otherwise, it will cause a huge problem to you. Provisions of creep anchors. How we provide keys to the rails? We have to provide extra fittings and fastenings to hold the rails onto the sleepers, and that is one type of provisions. Provision of providing steel sleepers. The steel sleepers, what do? They don't allow much creep. as with respect to the concrete or wooden sleepers. Right? We saw these are the three methods through which we can reduce the creep. You have to bring the rail back to its position, or you have to provide a creep anchorage, or you have to provide a steel sleepers. Right?